a set of points. Does anybody remember how to tell if this is a function or not? It's been a while since we've looked at a set of points. Yeah, of course.
If the same numbers and like the x or the y as well.
X over the y?
Well, like, if on all the coordinates, if they're in the same place, the same numbers in the same place, like in the x.
Okay. So I guess what I'm trying to get clarified here is if a graph looks like this, let's say this is the x and this is the y, and my line does this, what do you notice about that line that's special? What you should say is that all the y values are the same, right? It's a zero slope, all the y values are exactly whatever it is, okay? Is that a function? Does it pass the vertical line test? Michael says yes. So the y's can be the same. Can the x's be the same? Right. It's the x's. It's only the x's we need to look at. So if we don't have any repeats of the x's, it's a function. Now we can repeat the y's as many times as we want, but we can't repeat the x's. So this is a function. There's no repeat of the x. And the domain. It's been a while since we've seen one like this. X is an element. This is a discrete situation. It's a series of points, not a line. So we have to list the domain differently. We use these ellipses things that have taken me years to still not perfect. So do the best you can. And we start with our smallest number, which would be -7, and then -6. And I'm going to underline them as I write them down just so I don't miss any. And then the next smallest would be -2. And then the next smallest is 3, and then 8, right? So it's not a range of values. They're very specific. These are the values of the domain. The range, same thing. It's discrete, so I'm going to list them from smallest to largest. It looks like my smallest is 2. And then I've got a 3. And then I've got a 4. And I've got a 5 and a 5. I only need to list the 5 once, though. If you listed it twice on a test, I wouldn't count that against you at all. But you only need it once. Okay? So I don't think you'll see problems like 6 or 7 on the test, but I would like you to turn to the next page. Look at these two with me. Yes?
If it wasn't a function, would it solve it still?
You could still say what the domain and the range is, but you would just say, no, it's not a function. Yeah. Good question. All right. I'm going to cheat here for number 7 and 8. It's not really cheating. It's using our resources. I'm going to go and I'm going to graph this function. So to do that, if you've got one of the graphing calculators, you can do it along with me if you want. Go to y equals after you turn it on. And you'll want to put in -2. Not the minus, use the negative. The x is this number right here next to the green one. It's like xt and some other funky weird things, and there's an n. And then plus 7. Now I'm going to just graph that, and that's the upper right thing here. There you go. Now you may have more stuff on yours. So if it shows some other stuff, press zoom. I don't don't know whose that is, but it shouldn't be in your pocket. Zoom and the number 6. Press. So exit, exit, press zoom and the number 6, and then try to graph it again. Okay. Now, here's the graph. What's the domain? What's the domain? Allison? Yeah, that's right. We assume that this goes on forever, which it does. If I could make the calculator do that, which I can't. I'm not that. It's not that good. What's the range then? That. My timer went off weird. Okay. What's the range?
8
No, no. Negative infinity to infinity. Yeah, it's linear unless it's a vertical or a horizontal. The domain's going to be the same for any of these. Here's another way of thinking about it. Is there any number that I couldn't put in for x? Why not? Couldn't I put in 0? Could I put in 0.1? I could put in 7. I could put. There's nothing that I can't put in for x. I could put negative numbers. I can put positive numbers. That's what the domain is. Now, is there any number that I couldn't get out as an answer for y? Is there some value of x that I could plug in here to get, say, 3.3 for an answer?
Yes.
Yes. I don't care to know what that number is, but could I do it?
Yes.
Yeah. So is there any value that I couldn't get here? And the answer to that's no. We can get any kind of a response that we want. So let's look at this one. I don't think this one's going to be quite so friendly. I'll go back to y equals, and I'm going to put in 3. And I better clear all that. I'm going to raise that to the x power. So you've got to use your up arrow and your x for that. And if I graph that, what's my domain? Is there any number I can't plug in for x?
No.
Okay.
Plug in any number.
I can plug in any number. I totally agree. So the domain is x is the element of negative infinity to infinity. But are there any numbers that I can't get as an answer as a result? Is the range? If I go down here to say negative 5, is there a value? Can I get to negative 5 from here? No. Where does it start? Does it really start at 0? A little bit after that, right? So how do we show that? Not included 0. Good. And it goes up to infinity. Yep. So I can't get 0 or negative numbers out of this. But it doesn't matter what I put in. I can put negatives in there for an exponent, but I will not get a negative result. But I can get anything up to infinity. Or some big number like that. All right, and the last one that I was hoping to point out is number 16. Number 16 is a question. I think you need to plan on something very much like this to be on the test. Now, some of these you guys saw a similar problem on the quiz, right? That we just gave and going to take again. Where does f of x equal g of x? How do we know, where do we find where they're equal? Allison? That's right, it's where they intersect. There's two spots, here and here. So where does that occur? We should be making that answer in terms of 2 points. Remember, a point is always written in the form of x, y. Okay? Alphabetical. I'll let you figure those points out. What is g of 0 plus f of 0? G of 0 plus f of 0. G of 0 appears to be -4 and f of 0 is both, they're both -4, right? They're both down 4. Now, if I gave you a problem like this and you just wrote -8, should I give you the should I give you the points for it? No.
It's just like
Yeah, it's easy, but it's also easy to write -4 plus -4 and tell me exactly what's going on there with that -8. Okay? Because there's lots of ways I could get -8. It could be -2 plus a -6, right? But that wouldn't be correct. So I need to know how you get the answer. So make sure you're writing this part for me. Okay? If you want me to assume, then I'm going to assume you're wrong. Okay? On what interval or intervals is g of x greater than f of x? What does that mean to be greater than? Above, right. Is g of x greater than f of x here? No, it's below, right? How about here? Yep. How about here? So there's 2 intervals. When we give intervals, we want to say x is an element. What's the interval leading up to this point here? What would that be? I hear -infinity. 2. I think it's -8. -8, right? Would I include the -8? Isn't that a point where we've already said that I've marked it as being equal? So yeah, okay, I don't want to include the -8. And where else? 0 to infinity. Again, not included because at 0 they're equal. But just past 0, they're not. Alright, I'll leave that one to you guys. Okay, give those a try.